We're going to look at one of the most important kinds of arithmetic calculations that you will perform in this class, and that's the use of ratios to convert one given quantity to another given quantity. For example, it's known that there are 2.54 centimeters in 1 inch. This, by the way, is an example of a conversion factor that you will not be expected to memorize. It's also known that there are 12 inches in 1 foot. Again, you will not have to memorize the conversions within the English system or between the English system and the metric system. You do, of course, have to know the conversions within the metric system, and we've discussed that previously. Another conversion factor that is within the English system is the fact that there are 3 feet in 1 yard. And we're going to look at how we can use these conversion factors to convert some given quantity, for example, say 17 yards, into the equivalent number of feet. And the basic setup for something like this is to first ask the question, what's the given quantity? If I give you 17 yards as a quantity, and the question is, I want to know, for example, how many centimeters this is equivalent to, we look upon this as a problem in which I'm converting the number 17 yards into a different number, but the value is still the same. The quantity is still the same. It's just being expressed in a different set of units. Looking ahead and looking at the conversions that I've given you, I can see that I can convert, for example, yards into feet, and I can convert feet into inches, and finally I can convert inches into centimeters. And the reason I know this is because of the given ratios that I've been given here that have the units, the appropriate set of units. The whole strategy here is to start with the given quantity, in this example 17 yards, and apply a ratio in such a way that the denominator has the same units as the yards. So in this example, I've got 3 feet is 1 yard. So I'm going to simply write yards below and feet up top. And again, the numbers that go with that are the 3 and the 1. The units are more important, really, than the number itself. And you can see by setting it up this way, yards would cross-cancel. And arithmetically here, 17 times 3 would be 51. But I'm not going to... So, in other words, there are 51 feet in 17 yards, but that's not the question. We wanted to figure the centimeters. So we simply continue with our calculation. If I have feet and I want to know inches, again, I know I have to have feet below and inches up top. And so it'll be 12 inches and the 1 foot down below. So now what I've done is managed to convert the equivalent number of yards into the equivalent number of inches. I know that because the only units left standing at this point are the inches. But again, the question here is centimeters, so I'm going to carry on one more step here and apply a conversion again now that has inches down below and centimeters up top, and the numbers that go with that are 2.54 and 1 inch. What you have to do now is get your calculator and actually perform the calculation, which in this case, since all the numbers are above the fraction bar, it's just a question of entering those numbers into the calculator, one at a time. Notice here, as far as using the calculator is concerned, you don't really have to hit the equal sign anymore, so I'll simply go 17 times 3 times 12 times 2.54, and the calculator gives me actually a long number here, and we'll discuss significant figures later, but I'm going to write that as 1554 centimeters, and that's the answer to that problem. One more example here. If, say, I were to give you 415 centimeters and ask the question, how many feet is that? Again, I'm going to look at this just as a question of applying conversion ratios in such a way that I first have centimeters below, and of course the only conversion I have up here that has centimeters and inches, centimeters in it, is also the one with inches, so I'm going to write the inches here on top and the 1 and the 2.54 down below. And if I want to know feet, then again I know I want inches down below because I have inches up top, and feet up top, so that puts the 1 foot and the 12 inches. So the point about this with using the calculator is, notice I'm dividing the number 415 by two different numbers. And the way the calculator works, every number below a fraction bar is preceded by the divide operator. In other words, using my calculator, I'm going to type in 415, and then I type in divide 2.54, then I just hit the divide again, 12, and the number comes out to 13.6. So I'm going to write this as 13.6 feet. In other words, 415 centimeters is equivalent to 13.6 feet. Another situation you should be aware of here is if I were to ask you to, say, do a square conversion. For example, if I gave you something such as, say, 45 square centimeters and asked the question, how many square inches is that equivalent to? Notice here I'm going to have to convert using, the only conversion I've given you here is one that has centimeters down below and inches up top, and the numbers that go with that are 1 and 2.54. But here, since it's a squared value here, I have to put a square in my conversion ratio. So when I'm working with my calculator, I'm going to enter 45 and I'm going to divide 2.54. Then I must divide again 2.54 to come up with an answer that reads 6.97. I'm just going to round this to 6.97 square inches. Notice another way sometimes people prefer thinking of this is to write 45 square centimeters as a given and simply write the ratio twice. 1 inch over 2.54 centimeters, and then write it again, 1 inch over 2.54 centimeters, and the answer, of course, will come out exactly the same, 6.97 square inches. The important thing here is that if you're using a square conversion factor, don't forget to square everything inside the parentheses. That means the 1, the inches, the 2.54, and the centimeters. All those things have to be squared. If you're doing a cube conversion, which actually probably comes up more commonly in chemistry, then you have to do it 3 times. And I'll just give one example. If I were to give you, for example, 75 cubic inches and ask the question how many cubic feet that is, notice I could write here 1 foot over 12 inches, and I'm going to cube it, which means arithmetically I'm going to type in 75 divide 12, divide again 12, divide again 12, and that's going to give me an answer of 0.434 cubic feet. Again, I've divided 3 times by the number 12 because my linear conversion, 1 foot for 12 inches, is having to be cubed. Notice one thing students are sometimes confused about is if a volume is given, the units will be cubic inches. 75 cubic inches as a given is different, very different, from saying that I have a box, for example, that is 75 inches by 75 inches by 75 inches. In that particular case, the volume of that box would be 75 cubed, 75 times 75 times 75, which works out, according to my calculator, to be about 42,000 cubic inches. There's a very big difference here between giving a value as 75 cubic inches and telling you have a box that is 75 by 75 by 75 inches. One last point here, again, if, for example, I were to have 2 linear conversions that were necessary to convert, for example, say I gave you 150 square centimeters, and the question was, how many square feet is that? I have to square both conversion factors. In other words, I would start out by, again, having centimeters below and inches up top, and I'm going to square that, and it's 1 and 2.54, but if the question is feet, then again I write 1 foot over 12 inches, and again I square that one. So arithmetically, entering this into the calculator is 150 divide 2.54, divide again 2.54, then divide 12, then divide again 12, and the answer here comes out to 0.161 cubic feet. square feet, sorry, square, because we were doing this as square. So this is an important technique. We're going to be using this throughout the course, not necessarily converting centimeters to inches, but the idea of converting one given quantity to another given quantity using a ratio. And again, the whole key is to recognize, if you include all the units when you're doing this arithmetic, that a given unit of, say, centimeters has to be, you have to apply a ratio that has the same given units below the fraction bar, so the units cancel. The units are the trick here.